In this video, we'll be taking a look at the Lesson 4 packet. So the Lesson 4 packet is actually something that students should be able to work through for the most part on their own. So if you have access to a computer where you can access Google Chrome, Lesson 4 should be a packet that you do on your own. So please do that instead of watching this video if possible. Otherwise, in this video, I will go through the packet relatively quickly so that you can see what sorts of things you're supposed to be learning and supposed to be practicing in this video. So let's take a look at Lesson 4. The first 4 steps have you log into wescheme.org and save your document. So I have actually already done that, so let's start with step 5. Suppose we want to make an image that had 100 identical red triangles. You would have to write triangle 20 solid red 100 times. To make matters worse, if you want to change the color of all 100 triangles to blue, then you would have to repeat that change for all 100 expressions. There must be a shortcut, right? So what we're focusing on today is creating definitions, which can be thought of as shortcuts, to help us efficiently work through our code. So we name values in our language using define statements. Let's try one where we define the term shape1 to mean one solid red triangle. So letter A here asks us in the definitions window to type define shape1. Notice that shape1 is one word, okay, no spaces. Triangle 20 solid, which is a string between quotation marks, and red, which is also a string between quotation marks. Close the parentheses and then close the parentheses for the whole line of that definition. And letter B in your packet says evaluate shape1 in your interactions window. So evaluate means type it in and hit enter. And letter C says what happened. So you should be writing down in letter C what happened. We just got an error. That was actually supposed to happen. That was how this series of questions was designed. We did get an error, and it says that shape1 is not defined. So letter D in your packet says now click run at the top of the screen. So the run button is up here, and I've already clicked it. And in letter E it says re-evaluate shape1 in the interactions window and hit enter. What did you get this time? Now we got a red triangle. So the conclusion here is there's a specific button that you have to click after you write a new definition, and it's run. Clicking run after writing a new definition allows the computer to actually read the definition that you've typed in. Once you click run, you are able to use the terms you have defined. So in the definitions window, we're going to edit the existing definition of shape1 over here to be a triangle solid red, but instead of size 20, we want it to be size 40. So letter I in the in the interactions window, we're going to evaluate shape1. What did we get? We got the same red triangle that we got before. So I updated the definition, but nothing changed over here when I re-evaluated it. The reason that is I did not click run. Run is what allows the computer to read this new definition, size 40 in this case. Now when I evaluate shape1 in the interactions window, I get a larger red triangle. So in letter J, what did you get? The same triangle as in part F. And nothing had changed. But in letter K, when I clicked run, what did I get? I got a bigger red triangle because the computer had a chance to read the definition. Okay, so conclusion, each time run is clicked, the computer reads all of the definitions and adds them to the language. If a definition is changed, the computer will keep using the previous definition until the next time run is clicked. So run is very important whenever you change anything in the definitions window. All right, page 2. What's the reason for creating a new function called shape1? Now instead of typing out triangle 20 solid red, you can use shape1 as a shortcut. So that would be helpful if I wanted to continue to reference the red triangle over and over and over again. All right, in letter 8, add a new line to the definitions window. The new definition should be called shape2, and we want to define it to be a solid blue circle of radius 20. So with a little bit of thought here and a little bit of careful typing, I know that in order to define something called shape 2, I'm going to type it like this, and I want to define it to be a circle, radius 20, solid, and blue. Close parentheses, and when I click run, the computer will read the definition. It'll tell me if there's any errors, which there are not in this case. And now when I evaluate shape 2 in the interactions window, I get a blue circle. So I just created a shortcut, a definition, to get a blue circle. Okay, in number 9, you are asked to define 3 things. You're asked to define something called age, to be the number of years old that you are. You are asked to define another function called name, to be the string that represents your name. And then thirdly, a function called shirt color, to be the string that represents your current shirt color. So I'm actually going to do that all at once over here. In my definitions window, I want to firstly define something called age to be my age. So let's say I'm 55. I'm defining the word age to be 55. I'm going to leave it there. I'm not going to click run yet because I want to do parts B and C as well. So then I want to define a function called name to be my name, which has to be typed as a string. I'm going to say that my name is Mrs. Jones. Close the parentheses. There's my definition for name. Then thirdly, I want to define a function called shirt color. Notice there's a hyphen there and no spaces. And I want to define shirt color to be whatever color shirt I'm wearing right now, which let's say is dark blue. Notice that's one word. Now when I click run, and in my interactions window, I can now evaluate age. It knows that age represents the number 55. I can evaluate name, which represents the string, Mrs. Jones, and I can also evaluate shirt color, which is dark blue. So you can jot down for A, B, and C what were the outputs for those pieces of code. Okay, and number 10. Definitions are useful because we can use them in other expressions. For example, we could use shirt color inside another expression to always refer to the color of your shirt as defined in the definitions window. So letter A here asks me to evaluate in the interactions window circle 20 solid between quotation marks because it's a string, and then shirt color, which I do not need between quotation marks because it's actually a function. Remember, when I use shirt color over here, it's referencing back to the definition of shirt color. So now when I hit enter, and my cursor's at the end of the line and hit enter, I get a dark blue circle. If I went back and said, oh wait, my shirt is green today, and clicked run, the computer will reread that new definition. And when I type this back in, now that it read the new definition, it knows that shirt color is supposed to be a green circle. I want you to try letter B on your own, where you're asked to make an outlined square of any size that is also the same color as your shirt. Be sure to use the shirt color that you defined. So pause the video now and attempt to write down the code that you think would be used to answer letter B. Okay, so hopefully you've written down something that looks like this. Square, size, anything you want, any number. I'm going to pick 100. We want it to be outlined, which the correct term here would be outline as a string between quotation marks, and then we want it to be whatever color the shirt is. So since, remember, my definition over here was that shirt color is green, this square should come out to be green, which it did. It's an outlined green square. So that should be your code down at the bottom of page 2. Square, any size you want, outline, shirt color. All right, let's look at page 3. Page 3, create the following definitions in the definitions window and evaluate them out in the interactions window. Don't forget to hit run when you type a new definition. So what we're going to do in letter A is define a value called prize to be a solid green star. You pick the size. So I am going to define something called prize, which they told me, to be, and if I want to use the code for star, I know it needs its own set of parentheses, star, any size I want, solid, and green. Close the parentheses, click run, and now when I use prize over here, it is a size 40 solid green star. Okay, letter B, define a value called big that uses the function scale to make your prize 3 times larger. Okay, if you need help figuring out how to use scale, you can look back at the lesson 3 packet, page 7. But I am going to show you how to do this. So we want to define a function called big that uses the scale function. After you type in scale, you have to tell it how much bigger you want it. In this case, we want it 3 times bigger. And what is it that we want 3 times bigger? We want to make the prize 3 times bigger. So when I close those parentheses and click run, I notice I get no errors, which means that when I retype prize over here, I get that original star that I had. But now when I type big, I get a bigger star that's been scaled by a factor of 3. So back in the packet, let's take a look at number 12. In our programming language, variables can be defined. Here are a few examples. So we notice we have 3 define statements here, and there are 3 associated questions with it. So I'd like you to pause the video now, take some time to answer 12A, 12B, and 12C on your own. You should have gotten that x equals 4, y will equal 4 plus 9, which of course we can do that addition and actually get an answer there. And what will z equal? It'll equal x times 2. So based on the previous definition of x, which is 4, z will actually equal 4 times 2, which is 8. Right, and number 13, convert the following code definitions into algebra equations. The first 2 are done for you. So you can use these first 2 as examples to fill in the rest of this table. And then in number 14, we're converting the algebra equations into code definitions. So pause the video now and try the rest of this page on your own. Now you can go ahead and check the answers to these 2 tables, making sure that you have all of the correct punctuation, the correct symbols, the correct number of parentheses. Please be aware in number 14 that these are definitions, so you should have the word define for each of these definitions. And according to the equation over here, you should be defining the correct term appropriately. So this is the end of the lesson 4 video, part 1. So this was just pages 1 through 3. If you're looking for the rest of lesson 4, take a look at the part 2 video.